Welcome everyone to the 2020 Greater Vision Climate Smart Agriculture event, presented by CSU Monterey Bay's College of Business, College of Science, and the Grower Shipper Association Foundation.
Hello to everybody. My name is Megan Nunes. I'm the founder and CEO of Bountiful. One of the things that we as a company do at Bountiful is something called yield forecasting. And one of the ways that we do that is through data techniques that involve using climate and weather data, as well as a ton of other data sources. And so for myself personally, this session around the intersection of climate and weather really speaks quite aligned to where I spend my days. And I'm looking forward to kind of getting to have a conversation at various scales. Well, we'll start with Mike Clancy, who is from the Citizen Climate Lobby, and he's going to kind of give us a bird's eye view, if you will, of kind of the issues that are at hand around the intersection of climate and weather. So Mike, if you would like to get us started, please.
Well, thank you, Megan. And first of all, I'd like to say thanks to everyone who sponsored this event. It's a wonderful event, particularly Lisa Dobbins for putting this on. I'm going to show some slides. I'm going to provide an overview of the science pertaining to climate change, weather and climate change as pertains to agriculture. So bear with me here. We're going to go to some slides. And the first graphic I'm showing you here talks about the difference between weather, climate variability, and climate change. It's important to understand that. Three broad classes of phenomena in the atmosphere. And the thing that differentiates these phenomena is, in fact, increasing time scale and space scale. Now, time scale is just a fancy way of saying lifetime of a phenomenon. Space scale is just a fancy way of saying the size or the domain of influence of a phenomenon. And to the far left here, we have weather. Weather happens on time scales of minutes to months and space scales of 10 kilometers to about 1,000 kilometers, ranging from thunderstorms to blocking patterns in the jet stream. In the middle range here, extending from in time scales of months to decades, space scales about the size of the Pacific Ocean basin, we have climate variability, also known as internal variability or natural variability. And this involves things we're actually familiar with. For example, El Nino, La Nina. In the Atlantic, it's the Atlantic multi-decadal oscillation, things like that, which give us warm years followed by cold years, wet years, followed by dry years, and that sort of thing. And then finally, on the right-hand side of this graphic, we have climate change. Climate change extends from decades, centuries, even out to millennia, and is in fact a global phenomenon. Now, one thing I'd like you to take home today is the following idea, and that is if you're looking at climate change, if you're trying to understand climate change, looking at trends pertaining to climate change, you really need to be looking at records that are 30 years or longer. If you're looking at a record that's 20 years or shorter, you're not looking at climate change. You're looking at climate variability, or if you're looking at days to weeks, you're looking at weather. 20 to 30 years is kind of gray area, but you'd really like to be closer to that 30-year trend line if you're talking about climate. Actually, 50 years would be even better. So with that background, I want to show you this graphic, which shows the global mean surface temperature of the Earth by year from 1850 to 2017. Now, surface temperature over the ocean is the sea surface temperature. Over the land and over the sea ice is the temperature a few meters above the surface. Global mean implies average over the entire face of the Earth, from pole to pole all the way around. And these 5 different sources shown here all depict the same picture. And that picture is as follows. Beginning about 1900, there was a significant increase in temperature such that we are now running about 1.2 degrees centigrade above the pre-industrial level. Now, there was about a 30-year period of a slight decline here, but overall, we see over the last 120 years or so, there's been a significant increase in global mean surface temperature of the Earth, such that you have to go back about 125,000 years, that's 14 human civilizations in time, to find an Earth that's as warm as it is today. Note also these zigs and zags here. Well, that's in fact the climate variability we were just talking about. Just because you have a cold year following a warm year or a wet year following a dry year doesn't mean you start a new trend. That's the short-term, decades sort of variability, climate variability. What you really need to focus on, what we really need to be concerned about is the long-term trend, the 30-year or longer trend. So what's going on here? Well, in fact, it is the greenhouse effect. There is an overwhelming international scientific consensus on this matter. It is not in doubt. It is not scientifically in doubt. It has been settled actually decades ago. pretty straightforward. It works like this. The Earth is warmed by incoming solar radiation, also known as shortwave radiation. And the Earth cools in two ways: reflected shortwave radiation and outgoing longwave radiation, also known as infrared radiation. Greenhouse gases trap the outgoing longwave radiation and warm the Earth, the lower atmosphere, and the surface of the Earth. And finally, human activities increase greenhouse gases in the atmosphere and increase the warming. So what are these greenhouse gases? Well, these are listed in order of how much infrared radiation that they actually trap in the atmosphere. And top of the list is water vapor, which we perceive as humidity. Water vapor actually traps more greenhouse gas or more infrared radiation than any other gas, followed by carbon dioxide, methane, nitrous oxide, and the F gases, or the fluorinated gases. Note that I've colored these gases differently than water vapor. That's because water vapor is not driving global warming. Water vapor contributes to global warming through the water vapor feedback loop, but water vapor does not drive global warming. That's because water vapor is in fact in balance with the global hydrologic cycle. Humans are not putting water vapor into the atmosphere in any large amount, and the residency time for water vapor in the atmosphere is very short. These other gases that I've colored magenta here, these are the anthropogenic greenhouse gases. These, in fact, are the ones that are driving global warming. Humans are putting these gases in the atmosphere in large amounts. They are not in balance with any natural cycle, and they have a very long residency time in the atmosphere. In the case of CO2, or residency times ranging from decades to hundreds of years, actually thousands of years. So where are these greenhouse gases coming? They're causing this warming. Well, globally, it looks like this. These are the broad economic sectors that you can associate with greenhouse gas emissions. The top three account for about 2/3: electricity and heat production, agriculture, forestry, and other land use, industrial production. Those account for about 2/3 of the gas emissions. You might be surprised that transportation is actually pretty low, only about 14%. So agriculture plays a role here. And we'll break it out like this. About half of this sector is in fact ag globally. About 11% of global emissions are produced by global agriculture. More than half of that is coming from livestock, raising of livestock. About 6% of global emissions are due to livestock. You may have heard that famous saying, if cattle were their own nation, they would be the third largest emitter of greenhouse gases in the world, right behind China and the United States. Following that is synthetic fertilizers, mainly nitrogen-based fertilizers, which decay into nitrous oxide. Rice cultivation is huge, particularly in Asia, particularly with regard to methane production. And finally, various other things, such as burning of crop residues, tilling and plowing, which releases CO2 from the soil, and manure applied to soils, which releases methane. So it's a two-way street between climate change and agriculture. Agriculture affects climate change through the release of greenhouse gases and the greenhouse effect that we just talked about. But obviously, climate change also affects agriculture. And so the question is, what kind of effects would we be expecting here in California? What are the expected climate trends in California looking out to the end of this century? Well, what we can expect is continued warming and drying out of the state, particularly in Southern California. What we're looking at here is a long-term trend in soil moisture. And you can see particularly in terms of percentage change, you can see particularly in Southern California, the state is continuing to dry out rapidly. But even here in the Salinas Valley, we can expect continued drying. More frequent and intense droughts. In the worst case scenario of business as usual greenhouse gas emissions, by the end of this century, by 2100, we would expect severe droughts to happen about twice as often. So droughts that we would expect to happen about every 20 years, we would expect to happen about every 10 years, and so forth. And finally, one you may not have thought about, that is sea level rise. I don't expect sea levels rise is going to cause us to lose a lot of farmland in the Salinas Valley, but it is likely that sea level rise will exacerbate saltwater intrusion into the Salinas Valley aquifer, which is a significant issue for local agriculture. So that's it. And I hope I didn't hit you with too much stuff there, but that's kind of an overview of the two-way street between climate and agriculture.
Thank you
and
so
I'm
much.
going to end my share now and turn it back over to Megan.
Thank you. Thank you so much, Mike. And thank you for that overview of kind of separating out the views of weather and climate and how they relate together, and setting timescales to all of those things, because I do feel like that's one area that grossly goes kind of misunderstood, especially in a lot of these types of conversations.